23 said, I have 6 is less than y plus 19. All right, if you're somebody that does not like seeing the variable expression part of it coming on that right side, you can change the order of it, but it is important you're able to solve these, whether variable expressions on the right side or the left side, because you're going to see these quite often that are kind of a mixed up order. All right, so Michaela, this says y plus a positive 19. So I'm going to add a negative 19 to my positive 19 to make it 0. So I end up with y all by itself on the right side, and I have to add a negative 19 to my 6 as well. All right, well, 19 minus 6, 9 minus 6 is 3, that's 13. It's a negative, the negative number was the greater absolute value, so it's a negative 13. All right, so there is the solution to it. And then if I go to graph that, well, negative 13 is where it starts. So I'm going to do my 0 way over here. I'm going to count by 2. So this is a negative 2, and this is a positive 2, just so you guys know what I'm counting by. 4, 6, 8, 10, 12. Here's negative 12. So here is negative 13. And everything, the bigger side of my inequality is facing my y. So all my variables, all the values for my y have to be bigger than that dot. Does that help you? Awesome. What else can I do for you guys? Angela? All right, let's take a look at 33. Okay. So 33 says Jim has $87 to spend. All right, it says he spends $6 on socks. He spends at least $32 for shoes. How much does he have left for shirts? Now, what throws people off is that it has the at least part on the $32, on the amount for shoes. All right. That's not our whole. This is still the max that can be spent. How many of you guys see that? The fact that it said at least $32 means that this is an inequality. If it said there's $6 on socks, $32 on shoes, how much for shirts, that would be an equation. All right, but because it says at least, they could have said $6 on socks, $32 on shoes. How much money do they have possibly left for shirts if we have a maximum of $87 to spend? Stating that it's a maximum of $87, that also indicates that it would be an inequality. The possible amounts for shirts, that would also indicate that it's an inequality. So there's several different ways that we can indicate this is an inequality. All right, so Angela, you have to do parts equal to your whole. So a lot of you are still struggling or resistant to doing this. You're still kind of stuck back in 6th grade and 5th grade with just doing random subtraction. All right, I need you guys getting out of that because it's going to get harder the harder these problems get. You have to do parts equal to your whole. So in this instance, what is my whole? Anybody? What is my whole? Pierre? Excellent. The money to spend. All right. Is that a maximum that he has to spend, Pierre, or a minimum? That's a maximum. Okay. I need to know that when I do my parts. Okay. What are my parts? What are we actually spending money on? Anybody? What are we actually spending money on? Layla? Okay. Money for socks plus money for shoes plus what else? Excellent. Money for shirts. Now remember, this is our actual. So what can our actual be in relation to the maximum? That we have to spend less than the maximum, or can we spend more than the maximum? Come on, you guys all have to make this distinction. Here's our maximum. What can we do in relation to our maximum? What we do, does it have to be less than our maximum, or does it have to be more than our maximum? Mia? It has to be less than. We can't spend any more than that maximum. Can it be equal to our maximum? Yeah, it can. We can spend that $87. Why not, right? So now we've written our inequality. Parts, whole. This is a maximum, so what we're doing has to be less than or equal to our maximum. So Angela, are you cool so far? All right, I don't know how much we are going to spend on shirts. There's our variable. So if I set this up, my socks are $6. My shoes are $32 plus X is less than or equal to the $87 to spend. All right, so now I'm just going to finish this. So this is going to be 38 plus X is less than or equal to 87. I'm going to add a negative 38 to both sides. X is less than or equal to 49. Did I do that right? All right, so we have at most $49 to spend on shirts. And by the way, your dollar sign comes before your number. If it comes after your number, I'm marking you down. So pay attention to your dollar signs. Questions? You guys cool with that? All right, what else can I do for you guys? You guys good? Okie dokie, put this away, get your notes out. If you had a hard time with some of those game plans, I recommend you go back and practice those. You're going to see something just like any of those 4 story problems on your test next Tuesday. So, going through homework helps you see if you're still struggling with something or you're cool with it. If you're still struggling, go back and fix it, please. Practice more. Okay, so today is 11/4. We are in our last section. We have 4 days this week. You guys do not have school on Friday. All right, so we have today and tomorrow. Wednesday, I'm going to be giving you guys some worksheet reviews of the sections we've been doing. Thursday, I'm giving you your chapter review. Monday of next week, we'll be doing our chapter review for the test. The test will be Tuesday. So you guys can kind of see what we're doing for the next week. All right, so I highly recommend in preparation for your test that all of you guys look at me, please. I recommend that all of you over the next week just start flipping through your homework. Go back to some of the stuff that you know you have troubles with. Refamiliarize yourself with what was in this chapter and just start looking at it again. All right? If you know that story problems were a problem for you, don't wait until I give you the chapter review on Thursday to practice them. Just kind of go back to them. Go back to one each night and kind of remember how to do it. All right? Start studying now. So when you get to your chapter review in the weekend, it's an easy weekend of studying. You have the chapter review to do, but you've already kind of done studying for it. The chapter review is the minimum you should be doing. All right? Now that you've had one test for me, anticipate what type of problems you think I'm going to be putting on it. You guys can kind of figure it out. You've had homework quizzes. You kind of know the stuff I'm going to put on there. I highly recommend that you're repracticing every story problem that we've had. That would be a suggestion that I have for all of you. Because you know you're going to have story problems on that test. Okay? All right. So, we are jumping into 2.10 or 210. All right, we are still solving one-step inequalities. But these are going to be with multiplication or division. So let's review something for a second. When we had addition and subtraction, solving inequalities is exactly the same process as equations. All right, that's what we've done for the last couple days. Exactly the same process. It's just your solution that looks different. All right, so if we have something like x minus 3 is less than or equal to 5, the first thing we know that we have to do is adding the opposite. And then we all know that we have to add a positive 3 to a negative 3 to make it that 0. So I have x plus 0, or just x, is less than or equal to 8. So this process is the same whether it's an equation or an inequality. Well, this cannot be said for multiplication or division. All right, so when we have multiplication, let's start with multiplication first. When we have multiplication, one of the things when we talk about multiplication are coefficients. What is a coefficient? What is a coefficient? Romano? The number touched the variable, right? It's the number the variable is being multiplied by. Nice job. It's number the variable is being multiplied by. For example, 3x, that 3 is our coefficient. If I have x over 1 over 2, this is the same thing as 1/2 times x. I need you to understand that. Do you guys understand that? All right, so that's the same thing. I'm going to talk a little bit more about that as we get into division. So that 1/2 is our coefficient. So this is the difference with solving these inequalities. Someone knocking at my door. All right, so this is the difference when solving with multiplication. Solving inequalities with multiplication in them. All right, this is the big thing. When the coefficient is negative, you must flip the inequality symbol when solving. That's the big change. When the coefficient is negative, you must flip the inequality symbol when solving. All right, so let me show you what I'm talking about. So I want you guys to solve. Negative 9t is less than 36. As you can see here, my coefficient is a negative 9. All right, so what we're going to do is I have negative 9t is less than 36. How do I solve this? You're solving exactly the same as an equation. So if this was an equation, if this said negative 9t is equal to 36, what would you do to solve? Michaela? What's the operation going on between these two? So does subtraction undo multiplication? Divide by that negative 9, right? All right, so I'm going to divide by that negative 9. So this is multiplication. So divide by the coefficient. So I'm going to divide both sides by that negative 9. Well, my negative 9's cancel out. I'm left with t. What's 36 divided by a negative 9? Christiana? Negative 4. All right, since our coefficient was negative, this less than symbol flips to a greater than. That's what I'm talking about. Flip, because coefficient is negative. If the coefficient is not negative, you don't flip it. You cool so far? All right, so let's practice a couple of these, and then we're going to talk about a story problem. All right, so I want you to solve and graph the following problems. So I have 4x is greater than or equal to 40. That's my first one. There's my second one. I'm going to put a third one up. Yeah, you guys need your rulers out. So please solve all three of those and graph them. You have to use a ruler. Check with someone to buy you, see if you guys got the same thing. Use a ruler when you're graphing, please. Make sure you're using a ruler, please. Make sure that I can see what the dot looks like. Pay attention to if the coefficient is negative. Not any number. I don't care if the constant is negative. The coefficient has to be negative. right, so let's talk about some of these. Someone tell me, how do I solve that first one? How do I solve that first one? Angela? Excellent. I'm going to divide both by 4. So the 4's divide out. On my left, I have just an x. On my right, I have 10, right? All right, do I flip that inequality symbol or no? Why? No. Why don't? That has nothing to do with whether you flip the inequality, Angela. Look back on the notes. What indicates that we have to flip the inequality symbol? When what is negative? Excellent. What's our coefficient here? Not the 40. Remember, you guys, come on. The coefficient is the number the variables being multiplied by in your equation. What is our coefficient here? So, Angela, look at this. Look, what does this say? 4 times x is greater than or equal to 40. So what is my coefficient? 4. It's the number the variables being multiplied there. There is our coefficient. I need you guys to understand what the coefficient is. It's the number, as Romano said, it's the number touching the variable. It's the number the variable is being multiplied by. So in this one, we do not flip inequality because coefficient positive. Please make sure you're taking good notes on this. So Angela, what is that graph going to look like then? Excellent. So did you indicate that by putting like a 2 and a negative 2 on there? Sweet. So here's my 10. What kind of dot's going on my 10, Angela? Excellent. And what about my shading? Excellent. That's exactly right. Everything bigger. Make sure that I can see that it is a closed dot and that the shading goes to the right. Nice job. How about that second one? Somebody solve that one for us. Mateo? Excellent. Do you have to flip the coefficient or the inequality? No. Why? I agree with you, but why? Okay, guys, please think. I'm going to ask you why. So I need you thinking. Look back at the one that we just did and see why I did not flip the coefficient, flip the inequality, and then tell me now why I don't have to flip it. I need you guys being able to do this. I agree with you, Mateo, that we're not flipping it. Why are we not flipping it? Emerson? Yeah, the coefficient's not negative, right? The negative 21 is negative, but the coefficient is not negative. It is positive, so do not flip it. You have to be able to explain that, you guys. So on this one, the coefficient is not negative either. So I'm going to do an arrow to both of those because the coefficients are not negative. All right, so, Mateo, do you want to graph that for us? Okay. Yes, because all my variables are smaller, right? Yep, absolutely. Nice job. All right, someone do that last one for us. Layla? Excellent. Excellent. So I'm going to go ahead and kind of do an arrow there. And I'm going to write that down. Flip symbol because coefficient negative. Don't forget, you've got to think about that. Go ahead and tell me what to do now. Awesome. Excellent. How many of you guys are pretty cool with this? All right, let's talk about story problems. How in story problems do I know I have multiplication? What am I looking for? Come on, you guys. In story problems, equations, inequalities, it doesn't matter. What indicates that I have multiplication? Audrey? A rate. All right, so when we're talking about story problems, it's exactly the same thing as equations. We look for rates. We look for 3 times as much or something like that. Double, 3 times as much. But rates are typically what we look for. All right, we still do parts equal to our whole. So just like if we have addition, and that whole is our total maximum or minimum, and the parts are what we are actually doing. Just like when we're adding and subtracting. All right, so let me give you an example of what we're talking about. All right, an elevator has a maximum load capacity of 2,500 pounds. Suppose the weight of an average adult is 150 pounds. At most, how many average size adults can ride safely in the elevator at the same time? So at most, how many average size adults can ride safely in elevator together? Okay, how do I know, first of all, what do you see here? Tell me things that you notice when you're reading this. Kira? Absolutely, we have a maximum weight. Excellent. What else do we see here that jumps out at us that we need to notice? Alex? So we need to know this. What is that for us, Alex? Is that a rate? Isn't that a rate, you guys? How many of you guys notice that's a rate? So this is pounds per person, if we wrote that as a rate. Okay, so that helps us. That we know is one of our parts, right? How do I know that this is an inequality? How do I know that this is an inequality? Mia? Yeah, it says at most. That right there indicates inequality. All right, so we've identified the maximum load. We've identified a rate. We're looking for how many adults. So we're dealing with weight. We're dealing with number of adults. We have a rate. So we know that this is multiplication. So parts equal to our whole. What information again is my whole? What information again is my whole? Pierre? Yep, the maximum weight load. What makes up our parts? Michaela? So the weight per person. And what else? What math do I need to do? What do I always do with the rate? What do I always do with the rate? Because this is weight per person. This is total weight. So if I know the weight of one person, how do I come up with the total weight that is actually going to be in that elevator? Michaela? Excellent. Yeah, I'm going to multiply by my number of people. Remember, this left side, this is the actual total weight. That right side is the maximum weight allowed. So we are comparing our actual total weight to the maximum weight allowed. That's really what we're doing in all of these. We're talking about what our total is. Yesterday was a total amount of money that we were actually spending on socks and shoes and shirts in relation to the maximum that we have to spend. Here, we're looking at our actual total weight in that elevator in relation to the maximum or the minimum. And here it's a maximum. All right, so I don't know my number of people. There's my X. What inequality symbol am I putting in between the actual weight that's in the elevator and the maximum allowed? What can my actual be in relation to the maximum allowed? Does it have to be less than, or does it have to be greater than? Alex? It has to be less than. Alex, can it be the maximum weight? Yeah, so I have an equal to. So there is my game plan as an inequality. Somebody write my inequality that we're going to solve now. Put our numbers in. Come on. I'm just going to start calling on people because I don't hear your voices. Aaron, do this for me. So now I have my game plan. Just put the stuff in. What's the weight of one person? Excellent. How many people? Times X is less than or equal to, what's my maximum weight load? Excellent. My weight per person is 150 pounds times my number of people. That gives me my actual weight that's on there. All right, so now how do I solve this? Now how do I solve this? Come on. How do I solve it? Go ahead, Aaron. Excellent. So when I do that, I get X is less than or equal to. So off to the side here, you guys are doing that division. Well, 150 divides into 250 once. All right, that's 150. All right, so this is going to end up being 100. Bring that 0 down. So I'm going to try 6 and see what that looks like. So that's going to be a 0. That's going to be 30. Carry the 3. That's a 9. So I end up with another 100. Can you guys see that now this is going to start repeating? Can you guys see that? So this is going to be 16.6 repeating. So my X is going to be less than or equal to 16.6 repeating. What does that mean from a solution standpoint? So this is number of people. So based on this, I have X is less than or equal to 16.6 people. What does that mean? Can I put 0.6 of a person on the elevator? No. So what is my actual answer? How many people can I actually put on that elevator based on what that solution means? Frankie? Yeah, and if I put 17 on there, it's going to be too much, isn't it? All right, so the maximum number of people are 16 people. So the maximum number of people is 16 people. So make sure you're making sense of your answer. You guys cool with this? All right, you guys can go. Please use your notes as your guide in your homework. I don't want to hear someone say, I looked at my notes and it didn't help me. Your notes have to help you.